Okay, this purple region is the region in question, and we're going to revolve that region about the line x equals 6, this dashed green line, and we're supposed to use the method of disks and washers. Turns out it would probably be easier to use the shell method. But anyway, when you're going to use the washer method, you have to realize that your typical washers are perpendicular to the axis of revolution. So this red line from x equals 6 to the curve represents the outer radius. And this little black segment here, if I want expressions for horizontal distances, I need to solve this function for x in terms of y. So if I divide both sides by 8 and then take the cube root of both sides, this distance right here for every y between 0 and 8 is 1/2 the cube root of y. And so when I want to find an expression for the outer radius and then square it, which is what this is, I'll take the x coordinate at the right, which is 6, and subtract the x coordinate at the left, which is 1/2 y to the 1/3. So if I square that quantity, that's the outer radius squared. And the inner radius is the distance from the axis of revolution to the inside of the region being rotated. And that's a constant, 6 minus 1, which is 5 or minus 25. Okay, if you're actually going to evaluate this, you could square this binomial, combine some similar terms, find an antiderivative, and evaluate. Here's some answers. Here's g of y, which is that 1/2 cube root of y. And here's the evaluation, 65.345. Here's the answer using the shell method. 2 pi times the typical shells are parallel to the axis of revolution. That's the height of the shell, and this is the average radius, which is the distance from the axis of revolution to the center of a shell. And there's the exact answer. You were not asked to evaluate it, so this is probably the answer you're looking for. Okay, there you go. Hope that helped. If you have any questions, post a comment.